Okay, we're going to step up the degree of difficulty a little bit on this particular one. This one has two radicals. You will need to isolate them on opposite sides of the equation. So because this one is a minus, I'm going to add this to both sides of the equation. And at least it'll be positive on the right-hand side. Now I'm left with 1 plus the square root of x minus 3 now on the right-hand side. I do want to, now because they're isolated, I do want to go ahead and square both sides of the equation. However, just as in example 4a, I have a binomial, a plus b, that's going to have to be squared. On the left-hand side, the radical is eliminated, which is great. On the right-hand side, this is an a plus b squared, which is a plus b times a plus b, or a squared plus 2ab plus b squared. And so I think the easiest way is to just use the special products. This is a squared, or 1. We're going to multiply the 2 together, so it's 1 times this, so that'll just give us the square root of x minus 3. And then we're going to multiply it times 2, so it'll be 1 plus 2 times the square root of x minus 3, plus, and then square root of x minus 3 times the square root of x minus 3, or b squared, and that's going to leave us an x minus 3. We can go through and group a few things that look alike. We have enough room. We've got a 1, we've got a minus 3, so we can put those together. And looks like 2 plus the square root of x minus 3, so that's this. 2 times the square root of x minus 3. Then we've got a 1 plus a negative 3, so that's minus 2, and then plus x. On the left-hand side, we have 2x minus 5. One more time, I want to isolate this radical. So we went from 2, now we're down to 1. So it's similar to problem 4a now, except for it's a little more complicated still. Let's try taking the 2 to the left-hand side, and let's try taking the x to the left-hand side. So I did just the opposite. If it said subtract 2, I added. If it said add an x, I subtracted. So that on the right-hand side, these are gone. On the left-hand side, we have x minus 3 equals 2 times the quantity of the square root of x minus 3. You could divide both sides by 2. I think that's going to complicate things. I say let's just go ahead and square both sides of the equation just as it is. So yes, you can square if it has a coefficient without a plus or minus. So squaring both sides, and this is a special product. This is x minus 3 times x minus 3, or x squared minus 6x plus 9 equals 2 times 2 is 4, then times x minus 3, or the square root of x minus 3 times the square root of x minus 3. Finally, we're through with radicals. Everything is going to have to go to one side or the other, so I suggest we distribute on this side, and then we'll take everything to the left-hand side. So this is x squared minus 6x plus 9 equals 4x minus 12. We'll come back, find us a little more room. X squared minus 6x plus 9 equals 4x minus 12. And again, we're going to take everything to one side and set it equal to 0. So you're going to have to subtract 4x from both sides, and at the same time, we're going to have to add 12. So I'm just doing both of these things together so it can be set equal to 0. Should result in x squared minus 10x plus 21. So looking for, hopefully, factors of this trinomial that the two values whose product equals positive 21, their sum equals negative 7. So we're going to have an x and x for a positive product and a negative sum. They're both going to have to be negative. And I like 3 and 7. Algebraically, the zeros are going to be 3 and 7. The question is, will they both satisfy the radical? And in this case, when you check them, they both will. So wherein for A, we only had one value that worked, and for B, they both work. All right, hope you enjoyed this video. Talk to you later.